share my screen with you all now. Okay, so yesterday already we had seen linear independence, linear. That's all right. So yesterday we already had seen linear dependence and linear independence of vectors. And now I will go on to the product of vectors. So first we will have some applications and small definitions of dot product and cross product. So as you know that A dot B is modulus A modulus B times cos of theta. And we can also write this without this bar sign. I can write AB cos theta with the understanding that modulus A has been written as A and mod of B has written as B. That's perfectly all right. And this theta is the angle between the vectors. So we have got a vector A and you have got a vector B. And if theta is the angle between them, then you define A dot B is mod A mod B cos theta. This expression helps you to find the angle between vectors if needed. A word about notation. Suppose I write A square. What does it mean? I can write A square or modulus A square. Please be advised that they are all same. In fact, mod A square is nothing but A dot A. And so these all things are equal. It's also A square is A dot A. And if someone writes like A square, that's perfectly fine. You should not be surprised, or you should not think that this is A square, vector A square. What does it mean? Because vector A square is same as saying that mod A square, and it is same as A dot A. So this is not ambiguous. There is only one way you can read it. So that's perfectly all right. Or still simply I can write A squared. Now, one of the first things that you learn is the laws of vector algebra. So for example, how to expand something like A plus B whole squared. That is modulus A plus B whole squared, which I told you that this is same thing as A plus B whole square, although mostly I will prefer this. And you can also say this as A plus B dot A dot A plus B. So it means you are applying the definition that modulus x squared, or a small result, is x dot x. And so A plus B dot A plus B you can do termwise. So I'll write A dot A plus A dot B. So I am developing it, B dot A and plus B dot B. Now because dot product is commutative, so this number just becomes twice of A dot B. Does not make a difference. This is just A squared, and this I can write B squared. So I can write this as simply A squared plus 2A dot B and plus B squared. Or I can write this as A squared plus 2A dot B plus B squared. So this is one form, or second form, or third form. I want to waste more paper. I can write modulus A squared plus 2 mod A dot 2A dot B and plus modulus B squared. All are equivalent. I advise students to get used to one of them, whichever you like psychologically. We are all wired differently. Whatever you like, someone else may not like that form. So all are equivalent. So this is very crucial to develop. Now just think of your good algebra. In algebra you had x plus y whole square was x squared plus 2xy plus y squared. They are the numbers, either real or complex. So this is just famous sum of this one squares. Now similarly, if you write, if this becomes vector A plus B in the squared, then you are just seeing that this remains same. Sort of this is the modulus. So this remains A square only. Understanding that A dot A, this here dot enters like this, like A dot B. So you can still think of the same formula and say A dot B and plus then B squared. Or you can write again either modulus of a square and 2a dot b and plus modulus of b squared. So that's how we develop. So the first thing to do is to develop the expression. The same thing will be found useful in, say, complex numbers or matrices. For example, complex number, if you have to expand z1 plus z2 modulus squared, then we write that we again use the result that in complex numbers mod z squared is z times z bar. And so we write z1 plus z2 times z1 plus z2 whole conjugate. And then I write z1 plus z2 times now conjugate. So they break and they become z1 conjugate plus z2 conjugate. That is conjugate of sum, each sum of conjugates. As usual, you multiply term by term. The important word is term by term. So you're writing again z1 conjugate, z2 conjugate plus z2 conjugate, z1 conjugate plus z2 conjugate. z1 conjugate again becomes modulus z1 squared, and this is z2 conjugate plus z1 conjugate. They are different things, so can't write 2, and plus mod z2 squared. And so you got some expression. If someone goes to matrices, then you have got matrix a plus b whole square. So you're writing a plus b times a plus b. Again, term by term, a times a becomes a square plus a times b is ab plus ba and plus b square. Unlike numbers, they don't become twice ab. It's not always true. It's not always twice ab. We know this equals only when a and b commute. So in a nutshell, the important point that I'm trying to make is that take care in expanding. So first develop the expressions, have a command over it. They will help you in all the problems. So this is one simple thing. Similarly, if I talk in vector a square minus b square expressions, you know in real numbers it is x square minus y square is x minus y times x plus y. In vector, the same thing becomes a plus b and dot a minus b. You can again check term by term. There will be 4 terms, and 2 of them will cancel each other because a dot b and b dot a will come. So we get this kind of factorization. Similarly, if I want to get a plus b plus c mod whole squared, now things are getting nasty. But don't worry, we have got the same thing. So we'll first expand and then make sense of it. So a plus b plus c and dot, this is a plus b plus c. So we can write here this one. Now, if this is the case, then we will again write this way. So a dot a, this is a dot a, then a dot b plus a dot c. Start from b, you will get b dot a, b dot b, b dot c. That is term by term. C dot a plus c dot b plus c dot c. Now a dot b and b dot a, they are same, and that becomes 2 a dot b. So it means you will get here a squared, and then here you will get b squared, then here c squared. So a squared plus b squared plus c squared plus twice a dot b plus twice b dot c plus twice c dot a. It of course remind you of x plus y plus z whole squared is x squared y squared z squared plus 2xy plus 2yz plus 2zx. So this is same, but only thing is now it is vectored. So this dot comes in, this dot comes in, this dot comes in, and a squared is to be interpreted as a dot a, or same thing as modulus a whole squared. So we have enough of expansion. Now we are ready to go for some kind of problem. So my first problem concerns that given a and b be 2 vectors, so a and b be 2 vectors, and so a be 2 vectors, and k belongs to R, then you want to prove that a plus b, so modulus of a plus b whole square less than equal to 1 plus k times modulus a square plus 1 over k times modulus b square. For this to make sense, k cannot be 0, and so I may write k is or minus 0. So this looks like inequalities, but you can take care of it. We will develop the RHS or expand RHS. So RHS I will write, consider RHS 1 plus k modulus a square plus 1 plus 1 over k modulus b square. That equals, I can separate these. I can write modulus a square because the left side does not contain k. So let me take all terms that come with k together. So modulus of k square plus k times modulus of a square. That is simple opening up. Modulus b square plus 1 by k times modulus b squared. Let me pair them up. This is kb squared. So I'll write this modulus a square plus modulus b square and plus k modulus a squared plus 1 over k modulus b squared. Now focus on this expression. This is not vector. In fact, this is positive number, positive real number. It's like k and modulus a. You know that modulus a is of course non-negative. If a is not 0, it is positive. So these are all non-negative numbers. So on the left, on the right you have two non-negative numbers, k modulus a squared plus 1 over k modulus b squared. So I can apply AMGM on them. So let's number it 1. And let me apply AMGM that k times, this is, if you have any difficulty, you can think of a squared. That's perfectly all right. But then I will stick with this one. So k squared plus 1 by kb squared. And this is nothing but, this is only k of modulus a squared plus 1 by k times modulus b squared, right? Modulus b squared. So if I apply AMGM, I will get alpha plus beta, if they are non-negative, greater than or equal to twice of square root of alpha beta. So this can give you greater than or equal to twice square root of k times modulus a squared times 1 by k times modulus b squared. That equals, because k goes off, so that equals 2 square root of modulus a squared modulus b squared. Now modulus a, modulus b are positive numbers, so this will just give you 2 modulus a times modulus b. So it means you are getting now 1 as, this is so 1, let me erase this in. So because this is greater than equal to, so you will get this whole thing greater than or equal to, from here, greater than or equal to modulus of a square plus modulus of b square plus 2 times modulus a times modulus b. They are just like x squared plus y squared plus 2xy. So that equals modulus a plus modulus b whole square. Or you can also write simply as the way we have done, modulus a plus b whole squared. So we are done. We already have covered that modulus of a plus b whole square is modulus a square plus 2 times this one, a dot b plus modulus b squared. By the way, let me do this way, because we have just done this. We can change this to modulus of a modulus of b. This is this fact, this actually, you know that this into cos theta is a dot b. So we know that if I take mod on both sides, so mod of a dot b, so this one step I again rewrite. So modulus of a dot b, this number is modulus a times modulus b times mod of cos theta, so many mods. And so modulus of a dot b, this is less than or equal to mod a times mod b. That's because mod of cos theta less than or equal to 1. And so we could have written one extra line here, that greater than or equal to modulus of a square plus modulus of b square and plus, this is 2 modulus a modulus b. So that is greater than or equal to twice mod ab. So this is mod A mod B. So this we can write, and then we can have covered this expression modulus of A plus B whole square. Or you could have used the triangle inequality. That is, triangle inequality gives you modulus of A and plus B. This one, this is less than equal to mod of A plus mod of B. So we could have got the result using this one also after this step, in the form that modulus A square plus modulus B square plus 2 modulus A modulus B. I will first write this as modulus A and plus modulus B whole square, modulus A plus modulus B whole square, and by this triangle inequality it is greater than or equal to modulus of A plus B whole square. One just has to be very, very careful of all the operations, because the notation is quite big. It's like you're writing mod A and then you're writing this square bracket and all these things. So please take care. The next one is like this. Given PQ RS, they are the 4 points. There are 4 points in a space. So we'll say 3D space. Also, length of PQ, that is modulus of PQ, is given to be 3. Modulus of QR is given to be 7. Modulus of RS is given to be 11. And modulus of SP is given to be 9. It does not matter how these points are located. They may be, PQ may intersect RS, may not. We do not require these things. So all we know is that distance is given between P and Q, Q and R and S, and S and P. And now you want to ask something. The problem is to find PR dot QS. If you have got 4 points PQ RS, they may be in any order, just random I am taking. So if you have got any 4 points PQ RS, we have got 6 possible distances between them. 6 possible distances between them, or distances between pair of points. For example, here you have got PQ, PR, PS, then QR, then QS. So you have got PQRS, so PQ, PR, PS, then QR, QS, QR is repeated. So let me erase that. So it helps to think it like PQRS. So you're saying PQ, PR, PS, then QR, QS, and then RS. So you've got 1, 2, 3, 4, 5, 6. So there are the 6 possible distances between pair of points. This involves already 4 distances: PQ, QR, RS, SP, and remaining PR, QS are found here. It's a very charming problem. So let us get to the bottom of the problem, that what it really wants. What is the meaning of all this? So I'll derive an identity, which I will use in the next problem also. That is, for any points A, B, C, D, any 4 points, goes without saying in a space. Sorry about that. It is twice AB dot CD is AD square plus BC square minus AC square plus BD square. It's very useful entity which we'll prove. 2AB dot CD is AD square plus BC square minus AC square plus BD square. Let's consider right hand side. So I'll write AD square plus BC square minus AC square plus BD square as, let us assume that A, B, C, D has Poisson vectors A, B, C, and D. You can take one of them 0 also. That may simplify calculation a bit, but that will be at the cost of symmetry. So to preserve symmetry, I'm not putting any one of them is 0, although that is of course favored many of the times. Now this is AD as well as BC squared. So this AD is by definition, this AD is nothing but distance between A and D. So modulus of A minus D whole square plus modulus of B minus C whole square. So this is like this. And minus, you have got modulus of A minus C whole square and plus modulus of B minus D whole square. Now, all is left is simplify. We already know that modulus of A minus say B squared is A squared minus 2A dot B and plus B squared. So I can write this as A squared minus 2A dot D plus D squared. This is B squared minus 2B dot C plus C squared. And after this, I can write this, and this is negative of, so this is this, let me erase this. And then I can write negative, so minus this A squared minus 2A dot C plus C squared plus B squared minus 2B dot D plus D squared. We are just developing them, expanding them. And so you find that this A squared, B squared, C squared, D squared appears here also. A squared, C squared, B squared, D squared. So they go off. And what you're left with, that a big 2 is there. So this is 2A dot C. So this is plus sign. I'll write 2 twice. You get A dot C minus A dot D. That is combining these terms, this term and this term. And then is left is this one and this one. I can again combine them. So I can write minus twice in the same order B dot C minus B dot D. And so this gives me twice. I can write A dot C minus D, the first bracket, this is, and minus B dot C minus D, and which will reduce to twice A minus B dot C minus D. We have just used this, that A dot some vector X minus B dot some vector X, that equals A dot, that A dot and A dot X and B dot X. Okay, so we have used this like A minus B dot X, just follows by expanding this side better, and you get this one. So this is 2A dot B, and then the moment you write this thing 2A dot E minus C dot D, then you know that this is nothing but AB dot CD. So this is 2AB dot CD. In fact, AB is B minus A, but we can change that. So we can just take negative out from both. So 2B minus A and times dot D minus C, and that gives you 2AB dot CD. So we have established this result. 2A dot BC dot is this one. So let's write this, that we got 2AB dot CD is AD square, means you pair up A with this vector D, AD square, then BC automatically will pair up, AD square, BC square, no room, minus, then A will go with C, so this is AC square, and then BD square. Remember, all 6 distances are appearing. Here you have got AD appearing, BC appearing, AC appearing, BD appearing, and AB and CD appear with a vector sign on the left side. So these all numbers, these all expressions do come. So this is AB. So you have got this as AB and CD. So all 6 distances do appear. So we'll apply this simply to our problem. Our problem was, let me go back to the problem. Our problem was PQRS, this kind of thing. I can solve it here. So if there is enough space, so I can say that, okay, if, or let me go down. And so you are given now points. So PQ, let me copy the data. PQ is given to be 3, QR is given to be 7, RS is 11, and SP is 9. Now we know that 2PS dot QR, now that equals PR squared plus QS squared or SQ squared, and minus PQ squared plus RS squared. Now PR squared plus qs square. This 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 is pr. No, you want pr dot qs. You do not want this. You want pr dot qs. So you don't want this. This can't be calculated because numbers are not there. So in fact, you want pr dot qs. Let's check again what you want. So you want pr dot qs. You want pr dot qs because already you are given pq, qword, rs, sp. These two are not given. So you want 2 pr dot qs. That equals ps square and plus qword square and minus pq square plus rs square. By the result, we have proved. And so now is the time to plug the values. So ps square is 9 squared, qword square is 7 squared, minus pq squared is 3 squared, plus 11 squared, 81, and this is 49, and this is 9 and 121. To your surprise, this becomes 130, and this also is 130. So the answer is just 0. 0 has a special significance. This means that PR is perpendicular to QS. The direction PR is perpendicular to the direction QS. This effect will come again and again. This kind of result. If the numbers were so chosen that this was not 0, you would get some answer for it, positive or negative. Here it is 0. That tells you, or that signifies the fact that indeed the directions PR and QS are perpendicular. Let me quickly do a problem on this perpendicularity. So this is a corollary that you got, that if you have got AD square plus BC squared is AC square plus BD squared. If this is there, this will imply that the vector AB and CD, these vectors AB and CD, these vectors they are perpendicular, because you are getting this as 2ab dot cd, and so this is perpendicular. Based on this, we can do a good problem that talks of tetrahedron. So the problem says like this, that it's this one, that you know what a tetrahedron is. So I'll just draw one tetrahedron here. This is A, B, C, and then D somewhere here. So this is A, B, C, D tetrahedron. Now the problem says that in a tetrahedron, not only regular, they are saying any tetrahedron, if two pairs, that's a statement, and this is true, sometimes us also, if two pairs of opposite edges are perpendicular. So in a tetrahedron, if two pairs of opposite edges are perpendicular, then you have to prove that. So then you have to prove that the third pair of opposite edges is also perpendicular to each other, third pair. And second, that the sum of squares of two opposite edges is the same for each pair. So it looks big. So the problem says that in tetrahedron, it is given that two pairs of opposite edges are perpendicular. Fine. That means what? First, let us list opposite pairs. There are three pairs: AB, CD, AC, and BD. It's very simple. Just write two numbers here. Whatever left, write on the right side. So AB, CD, AC, BD, and AD, BC. You cannot do anything else. Suppose you write BC, AD. They are already counted. So no need to worry about it. So it means that there are three pairs of, they are what is known as three pairs of opposite edges, because it has got 6 edges, and out of them they fall in pairs. So ABC are opposite pair, then ACBD, then ADBC, they are the opposite pair of edges. Now the problem says that if in a tetrahedron two pairs of opposites are perpendicular, meaning that if somebody tells you that AB and CD are perpendicular, and also two pairs, so you can take AC and BD, any two you can take, in fact AC and BD are perpendicular. So it means if this is so, then you have to prove that remaining pair, that is AD and BC, in fact that also, they are also perpendicular. That's the meaning of if two pairs of opposite edges are perpendicular, then prove that the third pair of opposite edges is also perpendicular to each other. So we can start anywhere. So I can take this. Now we have just done this. It's straightforward. It will come by this. Because AB and CD are perpendicular, so we know that 2AB dot CD, which was equal to 2AB dot CD, was, we just derived that it was AD squared plus BC squared. So it was AD squared plus BC squared minus AC squared plus BD squared. And similarly, twice AC dot BD, this number I will write, that is AD squared plus BC squared minus AB squared plus CD squared. So these two you write, and also write twice AD dot BC, which equals AC squared plus BD squared and minus AB squared plus CD squared. Now you see that given these two are perpendicular, means AD square plus BC square is AC square plus BD square. AC square plus BD square is common here. So that also equals to AB square plus CD squared. That means that these two are equal. So AB square plus CD square is this much, or AC square plus BD square is this much. So these two are equal. And here I will, for our case, we will use these two equal, because that tells you that if this is true, then AC square plus BD square, in fact, that also equal to AB square plus CD squared. And so from this result, it will be equal. In fact, AC square BD squared, and this is not same. This is, here we have common, not this. We have common this, and then the other one is this one. AD square BC square is common. So the moment you equate these two, they are precisely here. And so that tells you that if these two hold, means if one holds and two holds, then 1 and 2 implies third also holds. So that is true. So it means you have proved this is true. And the second is the same fact. Second is saying that sum of squares of two opposite pair of edges is same for each pair. We already have proved that AD squared plus BC squared equals AC plus BD squared and equals AB squared plus CD squared. So we have proved that the sum of squares of two opposite edges is the same for each pair. So that was an application of the result we just knew. Let me do some more problems on this. So now, given A minus B squared plus B minus C squared plus C minus A squared is 9, and A, B, C are given to be unit vectors. That's a J advanced problem. You have to find modulus of twice A plus 5P plus 5C. Here I will again give you one result first. That result is this very important result, that let ABC, so if ABC are unit vectors, then A dot B plus B dot C plus C dot A greater than or equal to negative 3 over 2. And moreover, and so this is the result. This is some good result. And equality holds. And equality holds when A plus B plus C is 0. Means the sum of A, B, and C vectors is 0, then equality holds. Now, such kind of result is important because in the exam, suppose you know it beforehand, then it quickly tells you that the problem is solvable. You understand the problem better, and moreover, you can do it fast. So these small results or lemmas must be your friends. Now, I will prove this very easily. I'll form A plus B plus C mod whole square that we discussed. It was A square plus B square plus C square plus twice A dot B plus twice B dot C plus twice C dot A. Just like the real numbers or complex numbers in the numbers field, that x plus y plus z whole square is x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now we are just replacing AB by A dot B, BC. So one dot comes everywhere, and this A square is to be interpreted as modulus A whole square. So now if this is the case, then we already know that modulus of any modulus is non-negative, so this is greater than or equal to 0. In fact, any r, modulus r square is greater than or equal to 0, and modulus r equal to 0 implies vector r itself is 0. If you talk of 3D, then 0i plus 0j plus 0k, this has got modulus 0. This has got modulus 0. Others don't have. So this means that this is greater than or equal to 0. This we know. So that means a square, b square, c square plus 2 times a dot b plus b dot c plus c dot a greater than or equal to 0. So I can write this as 3 because unity vector 3 plus twice, let's call it some p. So 3 plus 2p greater than or equal to 0. That gives 2p greater than or equal to negative of 3. I can multiply by 1 over 2 both sides. So this is p greater than or equal to negative 3 over 2. Sign will not change as 1 by 2 is positive. So you got this. It means you got a dot b plus b dot c plus c dot a greater than or equal to negative 3 over 2. Now equality holds because this equality comes from 0. So it means here it is that modulus of a plus b plus c equal to 0. That corresponds to equality case. Equality case. So it's like mod r equal to 0, then you know that implies r equal to 0. Converse, of course, is to it is this way. So it means that gives you that in fact sum of vectors a plus b plus c, this also must be 0 because their mod is 0. So this is 0. If this is 0, then we are done. We want now modulus of 2a plus 5b plus 5c. Notice how they have given coefficient of b and c same. That's for a reason. I can write now twice of a plus 5. I can take common 5. And then we are good because you are getting twice of a, and b plus c from here equals negative of a. So 2a minus 5a, that is negative 3 times a. That is modulus of negative 3 and modulus of a. That is 3 times modulus of a. Because a, b, c are one unit vector, so 3 modulus a, so that answer will be 3. So this answer happens to be 3 integer type answer. If they ask you in J advanced, it is integer type. So what we did here, that we found out that this expression, this result was same as saying that if it's unit vector, this was same as saying that in fact from this you will get that a plus b plus c equal to 0. And the moment we get this as 0, then the problem is over. Let's do a problem which is little computation. So 3a minus 5b, this is given to be perpendicular to 2a plus b, and a plus 4b is given to be perpendicular to negative a plus b. Now what we want is we want the angle between vectors a and b. We can write acute angle. We will calculate angle between a and b, or no need to say, we can just say angle between a and b, because anyway we will needing a dot b. So this is little algebra. We'll write 3a minus 5b dot 2a plus b is 0 as they are perpendicular. That gives you that 6a squared. Again, you are expanding like this, 6a squared. So let me expand this here. So we next one we can do faster. 3a minus 5b dot 2a plus b, that is term by term. So first this one, so 3a dot 2a plus 3a dot b minus 5b dot 2a and minus 5b dot b. So that becomes 6a squared, 3a dot b minus 10a dot b and minus 5b squared. So we can write this as 6a squared. I will write a square only, and this is 3 into 2 6, and 3ab and minus 10, so that is minus 7 a dot b and minus 5b squared equals 0. This is 1. Similarly, a plus 4b and times, so dot minus a plus b is 0 because these are perpendicular. That will give you a squared, one term a squared, and a dot b coefficient is 1 from here, and here minus 4. So that will give you this is negative a squared. This will give you minus 3a times b, and plus 4b square is 0. To solve this, we employ what we call cross multiplication rule. What we call cross multiplication rule. I apply in this form, that if you have got a1x plus b1y plus c1 is 0, a2x plus b2y plus c2 is 0. So you can write x over y over 1 over. So x over you write here b1 c2 minus b2 c1. So you write b1 c2 minus b2 c1. Y over you can come from right, that is c1 a2 minus a1 c2, and 1 over you can write a1 b2 minus a2 b1. This we use as the rule for cross multiplication. We apply it here. So we write a square over negative of 7 times 4 minus negative of 3 times negative of 5 is a dot b over, this is minus 5 times minus 1, be careful, and minus 6 into 4, that is this one, and that is b square over 6 times negative of 3 minus 1 times minus 7. And so that gives you a square over minus 28, and this number is minus 15, is a dot b upon, this number is 5 minus 24, is b square upon minus 18, and this number is again negative of 7. So you get a square over minus of 43 is a dot b upon minus 19, and b square upon minus 26. You can again write this as a square over 43 is a dot b upon 19 is b square over 25. Let's call it k. Now cos theta, the angle between the vectors, is a dot b, and upon mod a mod b, remember mod a dot b is some number, so now a dot b is nothing but 19k, so I can write 19, so I can write 19k. Modulus of a is square root of 43 and times square root of k, and b square is nothing but 5 times square root of k, that k cancels out, and you are getting 19 over 5 root 43. So we can say that the angle between them is theta is cos inverse of 19 over 5 root 43. That's your angle between the vectors a and b. That's pretty good problem, but then it used algebra also and some other stuff like cross multiplication rule. And first of all, that you are, I did not bring theta anywhere. I just I just dotted this vector with this vector and got in this form, and I applied cross multiplication rule on a squared, a dot b, and b squared, and we got this expression. Again, further we continue to move. So now, given modulus a equal to modulus c equal to 1, modulus b equal to 4, and you are given that b cross c modulus is square root of 15, means whole lot of data is there, and b equal to 2c plus lambda a, you want to find lambda. One more thing is given, that is, we can say that b and c, the angle between b and c, the angle between b and c is given to be acute. Now, this kind of problem, how to approach now? You are getting b is 2c plus lambda a. So I will say that, I will capture it like saying that square an appropriate relation between the vectors involved. Obviously, this is what comes to our mind when I say this. Now, b is 2c plus lambda a. You want lambda. B is 2c plus lambda a. If I square by keeping lambda this side only, say if I square, I will get b square is 2c plus lambda a whole square. I will get terms of c dot a, which is not known here. B cross c is known, but c dot a is not known. So I will not use this. What I can write, I can rewrite it as b minus 2c is lambda a. Now I can square in this form because many things are known. So I will write b minus 2c mod whole square is lambda mod a square. Rather, we are doing this one first. B minus 2c whole square is lambda square a square. And this is the way meaning of this one, modulus b minus 2c. Now this, or we know, or no need to write this. We'll just quickly, we will work with this one because that will be good. So we'll work with this one. We'll get here b squared minus 4 b dot c plus 4c squared, and that equals lambda squared a squared. Now c squared, as I told you, is mod c squared. So b squared is given, and b squared happens to be 16. So this is 16 minus 4 b dot c you leave, and plus 4c squared. That 4c squared, so that is given to be just 4. And lambda square a squared mod a is 1. And so it is just lambda squared. So if I get to know b dot c, my job is done. Remember, I have given b cross c. There is other useful identity. That is b cross c whole square, b dot c whole square is b square c square. It is just sine square theta plus cos square theta equal to 1, because we know that b cross c is mod b mod c sine theta and n cap. So this is true. Now b cross c squared. Now when you see b cross c squared, we see that b cross c is given to root 15. So this number is 15 plus this is b dot c whole square, and this b squared c squared is, of course, it is given to be 16 into 1, so that is 16. So b dot c square is 1. If that is the case, then you are getting modulus of B dot C, or B dot C, simply we can write that B dot C. So it's like, so we will get this one, that this equal to 1. Now if you come here, if you come here, B dot C, this number here. So if this number is 1, then you will get 60. We got B dot C directly. So it means we will, and then of course we know that this is either 1 or -1, because B dot C square is there, it's a number. So B dot C is one of, we will take B dot C equal to 1, because given that B and C angle is acute, B and C angle acute, so of course B dot C must be positive. And so from here, if I go here, this will imply 16 minus 4 plus 4 is lambda square. That 4 cancels. Lambda square equals 16. And so your lambda, that equals either 4 or that equals -4. So lambda is 4 or -4. So that is your value for lambda. So here also we use this identity, this one. So please keep in mind these identities. They will they will help you solve the problem. Next, we do one geometrical application. So let me change the color maybe. So that is, you are asked that prove that the perpendicular distance, so you are asked that the perpendicular distance of point C from the line AB, joining the line we join A and B, joining A and B, is B cross C plus C cross A plus A cross B over B minus A. Now, when you see this problem, you quickly come to know that this is indeed geometrical, because you don't have anything like simplifying modulus. So what we see, that just ask ourselves this question, that B cross C plus C cross A plus A cross B, what is this number? What is this expression? This expression tells me something. This expression tells me something geometrically. So geometrically, this tells me something. If I can figure out what that is, my job is done. So remember that area of triangle ABC, so area of triangle ABC, vector area triangle ABC, is given by half. So vector area of triangle, so where is this? Vector area of triangle is given by half A cross B plus B cross C plus C cross A. If you want modulus of area, like area, you will just write this one. So this is the area of the triangle. It is easy to derive. You can take this as C, this is A, this is B. Just take anything, like say this one, AB cross AC, half. So I write half AB cross AC. So that is B minus A n times C minus A. So that gives you half, and this is cross. So B minus A cross C minus A, that gives you B cross C minus B cross A. Just collect terms, minus A cross C plus A cross A. A cross A is of course 0, because they are parallel vectors. And this is half B cross C. We know that X cross Y, cross product is anti-competitive. X cross Y is minus Y cross X. And so this gives you A cross B. And I can write this change sign to plus, because already cyclic. So that is C cross A, and this is 0. So I am getting is half A cross B plus B cross C plus C cross A. So this is your vector area. So this is your vector area. So let's call this is your vector area. The normal area is mod of that one. It's like some vector. So you have got area ABC as half and modulus A cross B plus B cross C plus C cross S. Now we are done. Now the moment you see this problem, you know that this ABC is there. So let's write it C, A, and B. Let height be H. This is the height H. Now if this height H is there, AB is C, or ABC is also distance between these 2 points. So this vector is A and B. So I can write this is modulus of B minus A or modulus of A minus B, which is same thing. They are symmetrical. Now this is AB. Now area ABC equals half into H into AB. Now half times H. H is H. I will write AB is A minus B. And ABC, just look here. ABC we got here, half A cross B. So I can write here half times half modulus of A cross B plus B cross C plus C cross A. This is what connects. So we are writing area of triangle ABC in 2 different ways. So we got in 2 different ways. They must be equal. And so this half cancels. And you are getting H as A cross B plus B cross C plus C cross A mod and upon modulus of A minus B. That agrees with the result that we asked, that it's here, that it is B cross C, C cross A cross B upon B minus A. So that same thing we are getting here. So one thing that I would like to tell about this problem, that this problem was actually geometrical in nature, although it was not obvious from the beginning. But then we saw that the expression A cross B plus B cross C plus C cross A, we are able to write this as, or able to relate it to area of triangle. And once area of triangle was there, then we are able to use this. And that's what we did, that we got the area and we covered this. And then we found half into base into height. Half into base into height we found. And also you found this area, and then we are able to find a height in terms of that. So let me now, it's time. So let me now stop sharing. Okay, so that's all for today. Let's meet tomorrow.